I want to identify the nth term of this sequence. It'll be 2/3, 3/4, 4/5, 5/6, etc. So always remember that for a sequence, we always start when n equals 1. So when n equals 1, our first term is 2/3. Let's look at the comparison here. How do you write 2 in terms of n? If n equals 1, 2 is n plus 1. And 3 is n plus 2. Because 3 is 2 more than 1, so we write n plus 2. Now, is this pattern true for the rest? Now, for our second term is 3/4. How do I write 3 in terms of n? Well, 3 is 1 more than 2, and 4 is 2 more than 2. Okay, so this pattern seems to be working. And you can also see that in the numerator, I'm always increasing by 1. And in the denominator, I'm also increasing by 1. So this pattern makes sense. Now for the next one, I'm given these two fractions for each term. Okay, so I can rewrite 2 to kind of have the same pattern as 1 plus 1 over 1. And for all these terms, I have the two ones are all the same. Okay, so we know that the nth term is going to have the form of 1 plus 1 over something. Now, this is the first term, this is the second term, etc. Notice how these are all the same. So the denominator is just n. So this is our nth term. Okay, last one. This was more complicated. So this one involves a fraction, but we're multiplying every other odd number in the denominator. And then in the numerator, we're just alternating signs. So it's not clear what we have to do. So one thing to note is, how do you represent an odd number? Because in the denominator, it's all odd numbers. We can represent it as 2n minus 1 or 2n plus 1 for an odd number. Okay, so keep this in mind. Now, we should actually first start off with the alternating signs, because that's the easier part. So you always want to have -1 to some power of n, but when n is equal to 1, I want it to be positive 1. But here, if I plug in equals 1, I get negative. So I either have to add 1 or subtract 1. I'm just going to choose to subtract 1. Okay. So if n equals 2, I get -1 to the 2 minus 1, which is -1. And that's exactly what I have. So this seems to be working. But in the denominator, I want to skip every even number, basically. Well, if I just left it as 2n minus 1 factorial, that would include all of the denominators. So like 1, 2, and 3. So let's look at an example of that. So if n equals 1, I have -1 to the 0 over 2 minus 1 factorial, which is 1 over 1, and that's 1. Okay, that's fine. But if I have n equals 2, it's -1 to the 2 minus 1, which is 1, and then 2 times 2 is 4 minus 1 factorial, so that would just be -1 over 3 times 2 times 1. And then if n equals 3, you have -1 to the third power over 2 times 3 is 6 minus 1 factorial, which is -1 over 5 times 4 times 3 times 2 times 1. In the sequence that we had, we did not have these even numbers. Okay, So what we have to do is eliminate them. How do we eliminate them? Well, let's find the pattern first. How do you represent this 2? This 2 is the same thing as 2 times 1. How about this 4? That 4 is 2 times 2. This 2 is 2 times 1. What if I go n equals 4? I have negative 1 to the third, to the fourth now, over 2 times 4 is 8 minus 1 factorial. So this is 1 over 7 factorial. But I want to eliminate the even numbers. So this 6 can be rewritten as 2 times 3. This 4, 2 times 2. And this 2 as 2 times 1. So notice, you're always going to have a 2 outside here, multiplying it. Okay. And then, so it's going to be a 2 to a power, and then you're going to have the rest. 3 times 2 times 1, which is 3 factorial. Okay. Let's go one more just to be clear with this. We have negative 1 to the fifth, and then it's 2 times 5, which is 10, minus 1 factorial. So that will be negative 1 over 9 times 8 times all the way down to 1. We said we want to eliminate all the even numbers. So for 8, you can write this as 2 times 4. As 6, 2 times 3. 4 is 2 times 2. 2 is 2 times 1. They all have a 2 in common, so we can pull that out. That'll be 2 to the fourth. And then we're left with is 4 times 3 times 2 times 1, which is 4 factorial. And if we compare that to the previous answer we got, the exponent increased by 1, and the factorial also, the number before the factorial increased by 1. So there seems to be a pattern. If we go back, this pattern is 2 squared times 2 factorial. And this pattern will be 2 to the first times 1 factorial. Now to put it all together, if n is 5, I have 2 to the fourth, which that is 2 to the n minus 1. And in the 4 factorial, 4 is n minus 1 factorial. Okay. So that's what I want to eliminate from the denominator. How do I eliminate from the denominator? Well, I have to put it in the numerator. So if I put that in the numerator, I'm good to go. And we can try this out for, let's see, this is n equals 4, to see if this is working. For n equals 4, you have negative 1 to the 4 minus 1 power, 2 times 4 minus 1, and then 4 minus 1 factorial over 2n minus 1 factorial. So that would be 2 times 4 is 8, minus 1 is 7 factorial. So that's 7 factorial. Now we can simplify this further. What we can't do is, we know that negative 1 cubed is negative 1, so we have a negative outside. Let's see. I'm just going to write it like this. 2 cubed is 2 times itself 3 times. And then 3 factorial is 3 times 2 times 1. 7 factorial is this. Now, I can pair these up. 2 and the 3 make 6. So that's going to get canceled. 2 and 2 make 4. 2 and 1 make 2. So I'm left with negative 1 over 7 times 5 times 3. and then obviously times 1, which is exactly what I have what I have over here, except obviously the order is a little different. Okay, so that seems to be working, and that is exactly our nth term.